Somewhere, right now, someone is wishing they could simply press pause. Freeze this exact moment before the good part ends, before the illness progresses, before the person they love walks out the door. It is one of the oldest, most universal human longings there is, the desire to reach out and simply stop the clock. I need to tell you something I have come to understand only after decades of studying the deepest physics we have. There is no clock to stop, not really. And the closer you look at the machinery underneath reality, the more you discover that stillness itself, true, complete, total stillness, may be one of the only things in this entire universe that is genuinely, permanently forbidden. Today we are going to find out why, chasing this question all the way from the edge of the speed of light down to the coldest temperature physics allows, and finally into the strange, restless heart of empty space itself. And if you want to keep exploring the deepest, strangest corners of physics with me, make sure you are subscribed, because I promise you, the reason time cannot be stopped is far stranger than simply running out of ways to slow it down. Let us begin with the closest thing physics actually offers to a pause button, something we have discussed before on this channel, but never quite pushed to its absolute limit. Time dilation, travel fast enough, close enough to the speed of light, and time genuinely does slow down for you, relative to everyone you left behind. Push that speed further, closer and closer to light itself, and that slowing becomes more and more extreme, approaching, in the mathematics, something that looks tantalizingly close to a complete stop. Picture a swimmer pushing against a current that grows stronger the harder they swim, until right at the very edge of some invisible boundary, they seem to hang almost motionless in the water, barely advancing at all no matter how hard they struggle. That is what time dilation looks like as you approach light speed, from the perspective of someone watching you from the shore. But here is the detail almost every explanation of this idea leaves out, the detail that matters most. The swimmer themselves never feels frozen at all. From inside that current, their own heart keeps beating, their own thoughts keep flowing, completely normally, exactly as they always have. Time never actually stops for the person experiencing it. It only appears to slow down from the perspective of someone standing outside, watching from a different frame of reference entirely. And there is an even deeper problem hiding underneath this, one that Einstein's own mathematics makes brutally clear. Reaching the speed of light itself, the one condition under which time dilation would become complete and total, requires infinite energy for anything possessing mass, an amount no engine, no civilization, no matter how advanced, could ever actually supply. The pause button exists only as a mathematical horizon, a line you can approach forever and never actually physically cross. Let us try a different approach entirely then, moving away from speed and towards something that sounds, on the surface, far more promising, cold. If motion itself is what drives change, what drives the passage of time in any meaningful physical sense, then surely, if we simply remove all motion, chilling something down as close to absolute stillness as physics allows, we should finally arrive at something resembling a frozen moment. Physicists call this theoretical limit absolute zero, a temperature at which, classically speaking, all atomic motion should completely cease. Scientists have spent decades chasing this limit in laboratories, using extraordinarily sophisticated equipment, cooling small samples of matter to within a fraction of a billionth of a degree above absolute zero itself. And yet, no matter how close they get, no matter how sophisticated the equipment becomes, they have never once, not a single time, actually reached it. And quantum mechanics tells us they never, ever will. Here is why, and I think it is one of the most beautiful, unsettling ideas in all of physics. The Heisenberg uncertainty principle tells us that we can never simultaneously know both the exact position and the exact momentum of a particle with perfect precision. If a particle were ever truly completely still, its momentum would be known exactly, precisely, zero, which the uncertainty principle simply forbids. This means that even at the coldest theoretical temperature the universe allows, particles retain a small, irreducible amount of motion, something physicists call zero-point energy, a permanent, unavoidable jitter woven into the fundamental structure of reality itself. Picture an enormous, elaborate dance floor where you have been told with complete confidence that the music has finally, entirely stopped. And yet, Looking closely, you notice every single dancer still swaying, almost imperceptibly, unable to fully come to rest, no matter how quiet the room becomes. That quiet, persistent sway is zero-point energy, and it means that true, complete stillness is not simply difficult to achieve in a laboratory. It appears to be forbidden by the deepest rules governing reality itself. There is one more place I want to take you before we close this first part of our journey, a place where time itself seems to genuinely, truly freeze, at least from a certain point of view. The edge of a black hole. Watch someone fall toward a black hole's event horizon from a safe distance away, and something remarkable happens. As they approach that boundary, their movements appear to slow down more and more, from your perspective, stretching out longer and longer until, mathematically, they appear to freeze completely, forever suspended at the very edge, never quite crossing over, at least as far as your own eyes and instruments could ever tell. But once again, exactly as with the swimmer approaching light speed, this apparent freezing belongs entirely to the outside observer, not to the person actually falling. From their own perspective, time continues perfectly normally, and they cross that boundary in a finite, ordinary amount of their own experienced time, feeling nothing unusual in the moment itself. The frozen moment we seem to witness from a distance is, in a very real sense, an illusion created by the extreme geometry of space-time bending light itself, not a genuine stopping of time for the person actually living through it. So here's where this leaves us at the end of the first part of our journey. Speed offers only an approach towards stillness, never an arrival. Cold offers only a persistent, irreducible jitter, never a genuine stop. And even the extreme gravity of a black hole only creates the appearance of frozen time for someone watching from far away, while time continues, uninterrupted, for whoever is actually experiencing it up close. If speed cannot stop it, and cold cannot stop it, and even the most extreme gravity in the universe cannot truly stop it, we are left with an uncomfortable, genuinely deep question. Is there something built into the very fabric of existence itself that makes stopping time anywhere for anyone under any circumstances fundamentally impossible? That is exactly where we are headed next. Stay with me. We discovered that speed only ever approaches stillness without arriving, that cold leaves behind a stubborn, irreducible jitter no laboratory has ever silenced, and that even a black hole's frozen horizon is only frozen for someone watching from far away. Now I want to take you somewhere even stranger, into the mathematics of quantum mechanics itself, and finally into empty space, the last place you might expect to find any motion left at all. Let me start with something that quietly troubled physicists for decades. In quantum mechanics, every system, no matter how isolated, no matter how carefully sealed away from the rest of the universe, is described by something called a wave function, a mathematical object containing everything that can possibly be known about that system. And here is the detail that matters most. That wave function is never, under any circumstances, allowed to simply sit still. It is governed by an equation discovered by physicist Erwin Schrödinger that forces it to continuously evolve moment by moment, forever, as long as the system exists at all. Picture a locked, sealed vault, completely isolated from the rest of the world, containing a single, undisturbed object inside. You might reasonably assume that inside that vault, with nothing entering, nothing leaving, nothing observing it at all, time itself might as well have stopped. But the mathematics tells a different story entirely. Even inside that perfectly sealed vault, the underlying quantum description of whatever sits within it keeps changing, continuously according to precise, unbroken mathematics, whether or not anyone is ever there to notice. This leads to something physicists take seriously enough to have given it a formal name: unitary evolution. The principle that the fundamental quantum description of the universe never actually halts, never pauses, never rests for any system, anywhere, at any point since the beginning of the universe itself. Stillness, in the way we imagine it intuitively, a genuine, complete cessation of all change, does not appear to exist as an option anywhere within the mathematics we use to describe reality at its most fundamental level. Now let me take you somewhere that sounds, at first, like the most obvious possible exception to everything we have discussed so far: empty space. Surely, if anywhere in the universe deserves to be called still, motionless, frozen in the fullest sense, it would be a region containing absolutely nothing at all. No particles, no light, no matter of any kind whatsoever. And yet, quantum field theory tells us something genuinely startling about this supposedly empty space. Even a perfect vacuum is never actually calm. Physicist John Wheeler gave this restless emptiness a memorable name, quantum foam, describing how at the smallest imaginable scales, pairs of particles and their antiparticles are constantly, spontaneously appearing out of nothing at all, borrowing energy briefly from the vacuum itself, before annihilating each other and vanishing again, all within fractions of an unimaginably small unit of time. This is not simply theoretical speculation either. It has been measured directly through something called the Casimir effect, where two closely spaced metal plates in a vacuum experience a measurable force between them, caused specifically by the restless, ceaseless activity of empty space itself. Picture standing in what you have been told, with complete confidence, is a perfectly silent, perfectly empty room, only to discover, listening closely enough, an endless, quiet, static hum coming from the walls themselves, present in every direction, impossible to ever fully silence. That restless hum is what physicists now believe fills every cubic inch of what we casually call nothing at all. There does not appear to be anywhere left to hide from change, not in speed, not in cold, not even in the deepest, most absolute emptiness the universe has to offer. This brings us finally to the largest possible version of this same question, the fate of the entire universe itself. We have discussed before on this channel how entropy, that steady, patient drift toward disorder, appears to govern the passage of time at the deepest level we understand. And we know that this process, left running for long enough, eventually leads towards something physicists call heat death, a distant future state in which the universe has spread its energy so evenly, so completely that no meaningful structure, no stars, no motion of any consequence remains at all. You might reasonably assume that heat death represents the genuine final stopping point of time itself, the ultimate pause button the universe eventually presses on its own. But even here, the mathematics resists a clean, final, full stop. Reaching a state of perfectly maximum entropy, mathematically, takes an infinite amount of time to fully complete, an asymptotic approach rather than a genuine arrival, the same way we discovered speed can approach light speed forever without ever quite reaching it. And even within that almost unimaginably distant, cold, and empty future, the same restless quantum foam we just discussed would, according to our best current understanding, continue its ceaseless activity regardless, a permanent, irreducible hum persisting even after every star has gone dark. Picture the very last ember of an enormous fire burned down over countless centuries to something so faint it is barely perceptible at all. Even that ember, examined closely enough at the smallest possible scale, is still technically, quietly, undeniably burning. There does not appear to be a final, complete silence waiting anywhere at the end of this story, only an approach towards stillness so gradual, so asymptotic, that true zero simply never actually arrives. So where does this leave us at the end of our journey together? We searched for a way to stop time at the edge of light speed and found only an approach that infinite energy could never complete. We searched at the coldest possible temperature and found a stubborn quantum jitter refusing to ever fully quiet down. We searched inside a sealed, isolated vault and found mathematics that refuses to stop evolving regardless. We searched inside what we call empty space itself and found a restless static hum built directly into the fabric of nothing at all. And even at the furthest possible edge of the universe's entire future, we found only an infinite, patient approach towards stillness, never a genuine arrival. Perhaps this is not simply a limitation of our technology, something a sufficiently advanced future civilization might someday overcome. Perhaps it points towards something far deeper, that change itself, the ceaseless, restless churn we have chased through this entire journey, is not something happening within the universe. It may be something closer to what existence itself actually consists of, all the way down, with nothing beneath it left to freeze. Exploring the honest, restless architecture hiding beneath our deepest human longing for stillness is exactly why I do this work, and exactly why I wanted to walk through this particular journey with you. If this changed the way you think about that impossible wish to simply press pause, then make sure you are subscribed so we can keep exploring these questions together. Tell me in the comments, honestly, if you somehow could freeze one single moment forever, knowing everything we just discovered about why the universe refuses to allow it, which moment would you choose anyway? Until next time, keep looking up and keep noticing the quiet hum that never actually stops.